Assalamualaikum and good afternoon to the panels that are watching this presentation video. My name is Fareez bin Muhammad Yussof and I'm a student from University Malaysia Pahang. So in this video, I'll be presenting my thesis. The title for my thesis is Earthquake Analysis of Single Story Bungalow under Acheh Earthquake. So this is my presentation outline. As you can see, there are a total of 10 parts for this presentation. So without further ado, let me start with the first part, which is the introduction. So what is earthquake? Earthquake is the sudden movement of earth ground caused by the release of stress which often occur along fracture or fault within the lithosphere. This event will produce a seismic wave that will result in a significant ground shaking, which can also trigger other threats such as liquefaction, tsunamis and landslides. Geographically, Malaysia is located in a stable region which is outside of the ring of fire, such as shown in the picture on the right side here. Therefore, Malaysia is known to be the country that are free from earthquake and volcanic eruptions. Earthquake can cause massive facilities and economic losses, such as the collapses of man-made structure, for example, buildings, roads, bridges, and so on. So the next part is the problem statement. So as I mentioned earlier, Malaysia is known to be the country that is free from earthquake and volcanic eruption. However, the exposure of Malaysia to the earthquake risk at present has substantially increased over the years. This is because the active plate tectonic, such as in Indonesia, has moved a few centimeters every year, which has caused it to be closer to Malaysia. Therefore, due to the movement of the plate tectonic, the countries in Peninsular Malaysia are likely to experience tremors when regional earthquakes strike the neighboring countries such as Indonesia. For example, in December 2004, when a major Indian Ocean earthquake struck Bandar Acheh, Indonesia, a tsunami occurred in Malaysia. Added to that, according to Malaysian Meteorological Service 2002, the earthquake originated from Sumatra, Indonesia has caused several cities in Peninsular Malaysia such as the Penang, Port Klang and Old Klang Selangor to experience the earthquake effect. This event has caused a major damage on people and buildings around the affected area. Therefore, this has proven that this natural threat needs to be properly quantified and analysed in order to reduce the damaging effect on the earthquake on the structure, since most of the buildings in Malaysia were designed without considering the earthquake loading. So the next part for my presentation is the research objective. So there are three main objectives for this research. First, to study the behavior of an existing single-story bungalow under Acheh earthquake. The second objective for this research is to observe the dynamic characteristic of the single-story bungalow when seismic loading are applied. And the third objective is to propose the resistance of an existing single-story bungalow based on the analysis that are conducted. So the next one is the scope of study. So the scope of study for this research is first, the earthquake analysis is conducted on an existing single-story bungalow which is located in Selangor, Malaysia. The second scope of study for this research is that the structural modelling and earthquake analysis are carried out by using SAP 2000 software. And the third one is that the input parameter in the analysis are defined based on Acheh earthquake data that are obtained from the Malaysian Meteorological Department. So the next part will be the expected outcome for this research. The first expected outcome of this research is that I'll be able to determine the performance and capability of an existing building to withstand the earthquake. The second one is that the result that obtained from the analysis conducted can be used to propose structural modification if it is necessary. So the next part of my presentation is the literature review. So basically, these are some of the articles or journals that I have used in the literature review chapter for my research. So mainly the purpose of this journal and articles is to help me in understanding the research process and also to gain more knowledge regarding the earthquake analysis. So the next one is the research methodology. So the figure shows here is my research methodology flow diagram. As you can see, this research flow diagram consists of 3 stages, where the first process starts with the selection of research topic, and the last process will be in the third stage, which is the submission of the research paper. So for my research, the software that I'm using is AutoCAD, SAP 2000 and Excel. AutoCAD is used to view the obtained architecture and RC drawing of the single-story bungalow. As for SAP 2000, it is used to generate the building modeling and also used to carry out the earthquake analysis of the single-story bungalow. And as for Excel, it is used to organize the data and result that are obtained from the analysis conducted in SAP 2000. So as for the data collection, there are 4 groups of data that are required, which is a drawing of an existing single-story bungalow, Acheh earthquake data, which can be obtained from Malaysia Meteorological Department, structural loading, which is dead load and live load, and also the data that will be used in defining the earthquake load in SAP 2000 software, which is structural ductility class and behavior factor, which can be obtained from Eurocode 8, peak ground acceleration PGA, building importance class and importance factor, which can be obtained from Malaysia National Annex to Eurocode 8, and finally the soil type, which can be obtained from the previous or existing study. So the data that I use in defining the earthquake load in SAP 2000 software are listed such as shown in the slide here. So the next one is the design simulation. For the design simulation, there are two design cases that are carried out in this research paper. The first case is designed based on Eurocode 2, which is by only considering dead load and live load during the design simulation analysis. As for the second case, the BD model is designed based on Eurocode 8, which is by considering dead load, live load, and also the seismic load. So the first design simulation is carried out on the as-built model, which is the BD model that are generated according to the drawing. And the second design simulation is carried out on the proposed modified model, which is the BD model that has been modified to resist the earthquake load without having any frame member failing during the design stress or capacity check. So the next part of my presentation is the result and the discussion. So there are three load cases that are considered in the analysis, which is the model analysis, non-seismic analysis, and seismic analysis. So from the model analysis conducted, there are 12 mode shapes that are obtained for both of the models, such as shown in the table here. So based on the table here, we can see that the first mode produced the highest value of natural period with the lowest value of frequency for both of the as-built and modified model. We can also see that the frequency value obtained in each mode for the modified model is higher compared to the frequency value that obtained for the as-built model. The second result that obtained from the analysis conducted is the joint displacement and acceleration value. From the displacement versus load cases bar chart here, we can see that there is no increment in the joint displacement value in both of the cases for both of the as-built and modified model. Meanwhile, as for the joint acceleration, we can see that there is no acceleration in the joint for case 2, which is the non-seismic analysis in both X and Y direction for both of the model. So the next one is the result that obtained for the frame axial load, shear force, and bending moment value. So from this bar chart here, we can see that there is no increment in the axial load, shear force, and bending moment value in both of the load cases for both of the model. From the bar chart here, we can also see that the axial load and bending moment value of the modified model is higher than the axial load and bending moment value of the as-built model. Meanwhile, the maximum shear force value of the as-built model is higher than the maximum shear force value of the modified model. So for the conclusion, it can be concluded that all the objective for this study has been successfully achieved. So for the first objective of this study, it is achieved by comparing the difference in the value of axial load, shear force, and bending moment of the selected frame that are obtained from the analysis conducted in before and after the earthquake load is applied. Therefore, from the result obtained, it can be concluded that there are no changes or increment in the axial load, maximum shear force value, and the maximum bending moment value before and after the earthquake load is applied. This is mainly because the Acheh earthquake magnitude is low and it does not pose a huge effect on the building's behavior, which is in terms of axial load, shear force, and bending moment. So for the second objective, it is achieved by comparing the obtained mode shape along with its natural period and frequency, and the joint displacement and acceleration value. So based on the model analysis, the highest natural period is obtained in mode shape 1 for both of the as-built and modified model. However, the modified model obtained a much lower natural period with a higher frequency compared to the as-built model. This is mainly because of the increase of the building mass and stiffness due to the increase in the size of the column and also the number of reinforcement bar used in the proposed modified model. The second objective is also achieved by comparing the joint displacement and acceleration value, and it can be concluded that there are no changes in the joint displacement before and after the earthquake load is applied, while there is no acceleration in the joint before the seismic load is applied. So for the third objective, by checking the frame member stress or capacity check in SAP 2000, an appropriate earthquake resistant modification was proposed for the modified model in order to make sure all the frame member pass during the checking process. As a result, from the proposed modification, which is by increasing the number of the column size and also the number of reinforcement bar used, all the frame member has passed the stress or capacity check. The result that obtained from the analysis conducted on the modified model are also compared with the result that obtained from the as-built model. Therefore, from the comparison that has been done, it can be concluded that the proposed modified building model has a better earthquake resistant structure compared to the as-built model. So for the final part of my presentation, here are the list of references that are used and included in the presentation slide. So I think that's all from me. Thank you for watching my presentation video.